Calculus! This is AP Calculus, Unit 9 Pretest. All right, so we're going through the whole thing. This is going to be the key. I'm going fast. I'm going furious. Here we go. This is number 1. This is with the calculator, so we will be needing that. We have this temperature in a tub modeled by T, blah, 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 blah. We're using the table to estimate W prime of 12. So 12, where does it exist? In between 9 and 15. That was one of our errors that we caught. So 12 is between 9 and 15, so I'm going to be using 9 and 15. I'm using this secant line. So I say that W prime of 12 is approximated by. So this is approximated by. Now I'm going to do W of 15, which is 67.9. So I'm doing the Y value, or the WT value. So 67.9 minus 61.8, and then on the denominator, I just do 15 minus 9. 15 minus 9, and let me open up my calculator. Do we all have a calculator also? I will hand that out. All right, now we all have a calculator. Let me pull up my calculator as well. Open recent TI-83 Plus, there we are. All right, so now I have my calculator, and I can actually type this in. This is going to be 67.9 minus, I guess I can do this all in my head. It's really going to be 6.1 all over 6. So just coming back over here, this is going to be equal to 6.1 over 6. And you can leave it like this, or you can actually turn it into a decimal approximation. I'm going to be rounding it here, so I'm going to do approximately equal to, let's clear out of that, 6.1 divided by 6. And round to 3 decimal places, that's 1.017.
Would you take off the point on the test if we don't round?
If you left it as a fraction? If you leave it as a fraction, I'm not going to take a point off. That's as simplified as the fraction can get, unless you multiply the top and bottom by 10. But yeah, so you can either say 6.1 over 6 or 1.107, and that is 1 point right there. That was 1 point if you got that. And then it also asks to interpret the meaning of your answer in the context of the problem. So what does W prime of 12 mean? W prime of 12. Well, W of 12 is just the degrees. So if I take the derivative, now I'm adding on minutes to the denominator. It's degrees per minute. So this thing means it's now a rate because it's per time. So it's the rate of change means the rate of change. And then we have to always include units in degrees Fahrenheit per minute now of the water temperature. I'm just going to abbreviate and say temp at time equal to 12. And that's going to be minutes, 12 minutes.
Can I say T equals 12?
At T equals 12, that is perfectly fine. In fact, that's probably a little bit quicker. And that's another point right there. Questions on 1A. All right, we're going on to 1B. Again, the rules are if you got 2 out of 2 points on B, you can ignore me and work on your fix-up. If you missed even 1 point, you need to be with me. All right, so I'm going to use the data in the table to approximate my integral of W prime of T, and then I'll have to interpret that meaning. So I'm going to say here, this 0 to 20 of W prime of T, dt, that is going to be approximated by, well, what happens when I take the integral of the derivative? This is the fundamental theorem of calculus. The integral of the derivative, they cancel each other out. And you're just left with W of T, evaluation bar between 0 and 20. And then I just plug that in, and that's going to be equal to capital W of 20 minus capital W of 0. And I have those values on my table, luckily, so it's going to be 71 minus 55. So that's going to be equal to 71 minus 55. And that is equal to 16 degrees. Don't forget your units, degrees, Fahrenheit. And we'll box it. That is our answer here. We should be boxing our answer up here. All right. So just by doing that, that is going to give you 1 point. And it also asks us to interpret the meaning of this. So what does this integral from 0 to 20 of W prime of T mean? This means, well, if it's an integral, it's going to be talking about total change. And in this case, it's going to be total change in the water temperature. So total change of the water temperature. And we'll always include the unit, so in degrees Fahrenheit, And then from where to where, for what were our bounds? So from 0 to 20 minutes.
It's funny how it looks easy, but then when you do the test,
What do you mean it looks easy?
like it's easy to do it. That's the thing. Like it's easy steps. But when you're on the test, it's like, oh god, what am I supposed to do?
That is, yeah, that's the hard part. You have all these tools that you're really adept at using, but knowing when to use the tools, how to interpret the problem, to figure out when to use the tools, that is the really hard part. And I agree. The only way to really learn that is by doing it over and over and seeing which case needs which tool. So the reason that this is the total change is because I have a rate. Remember, w prime of t, we interpreted that up here, is a rate. The integral of a rate is the total change. And we've been talking about that before in previous units also. The integral of a rate is total change. You have to have this word total change
And that's kind of
to get 1 point.
It was kind of when you put it on the pretest, it was pretty confusing on why we had to put total change of water temp in Fahrenheit. Like it's a lot of description. You don't really like notice until like once you get graded.
Yeah, that's a good point. All right, we're on to part C now. So if C was out of 3 points, if you got 3 out of 3, you can ignore me. If not, you are following along with me. So for this one, it says I need to find this average temperature. I'm just going to rewrite this. I'm going to say, okay, this 1/20th of the integral between 0 and 20 of w of t dt. This is going to be approximated by my left Riemann sum. My left Riemann sum. So if I'm looking at my table up here, a left Riemann sum is going to have this general shape. So it kind of has this, the left two most points on the table are going to be used. So I need to find the distance between 0 and 4, which is 4, and I'm going to multiply this distance between 0 and 4 by 55. So I'm going to say 4 times 55. This is going to equal 4 times 55.
Wait, so the left one is the one that's pointing right.
Yes, it's pointing right, or you use the leftmost points.
Super annoying. Okay.
And then I do my next shape. My next shape is going to look like this. I use the distance between 4 and 9, which is 5, and I multiply 5 by 57.1. So plus 5 times 57.1. And I have to go all the way to 20 because the bounds are 0 to 20. Next, I'm going to do this shape where it's pointing to the right. I'm using the leftmost points. The distance between 9 and 15 is 6. So I'm going to multiply 6 by 61.8. 6 times 61.8. Next, and finally, my last part of my left Riemann sum is the distance between 15 and 20 is 5, and I'm going to multiply 5 by 67.9. So 5 times 67.9. And don't forget, I forgot something, you guys see it? Don't forget 1 over 20. This whole thing now is going to be multiplied by 1 over 20. This whole thing here, let me go ahead and grab all of that so I can move it over. That whole thing is going to be multiplied by 1/20th. I still have this 1/20th on the outside, 1 over 20. And this is where you just do it all in your calculator because we are allowed to use a calculator on this one. So 4 times 55 plus 5 times 57.1 plus 6 times 61.8 plus 5 times 67.9. That all is 1,215.8, and then I need to divide that by 20. Divide by 20. And I get 60.79, so this is equal to 60.79, and our units here are going to be, it's just our degrees, because this is counting the total, the average temperature. So whenever you have this word average, it means don't change the units. Use whatever units it's talking about. Average is talking about temperature, so use the units for temperature, which is degrees Fahrenheit, and box it. All right, how to score yourself, or where you might have got points. So you got 1 point for the Riemann sum setup, so 1 point if you got all of these values correct. You got 1 point if you actually got the answer. And we need to answer the rest of the problem, which is this approximation an overestimate or an underestimate of the average temperature of the water? Okay, the answer here is we need to ask if it's increasing or decreasing. Are all of these values increasing or decreasing? Every single one is increasing. So you have to say that this is going to be an underestimate. It's kind of like the opposite, underestimate, because, and then technically you need to say strictly increasing, but if you say increasing, I believe you still get the point. Strictly increasing. Are you eavesdropping on that, Ben?
Yeah.
So I would prefer you to always say strictly so that you know that's increasing all on that interval. Strictly increasing on the interval 0 to 20. So if you said that it was an underestimate with this rationale, with this correct reasoning, you get 1 point. And this was out of 3 points.
W prime of t. That means the same thing, right?
If you say w prime of t is greater than 0 on this
It's
interval,
increasing it on 0 to 20.
w prime of t, you don't know that, so you're saying that the slope is increasing. By saying the slope is increasing, you mean that it's going like this. We don't know that. It might be like this, this, and this. You don't know that the slope is increasing. You know that the heights are increasing.
So it's better to say strictly increasing?
So I guess to be very technical, you need to say it's increasing because w is strictly increasing. Because w of t is strictly increasing. Not w prime of t, but w of t.
Then I got it wrong.
Oh.
I should have gone 2 out of 3.
I messed up on the grading of that. Thank you for being honest. I'm still going to give you the point because you're going to get full points after doing the fix-up, but thank you. All right, so for D, now we're saying we need to get this equation is modeled by w prime of t. This is a rate. W models the water temperature, so w prime of t is the rate of the water temperature change. I need to find the temperature at time equals 25. So if w prime is a rate, this is a start plus change equals n problem. So for the t value, what is the start? I need to add the change, and then I have to get the n value. So for the t value, I'm looking at the t value of 25. The start value, well, the start value is this starting at 20. So at time equals 20, it started at 71 degrees. Because again, we're now cooling off. We have heated up our water, and now we're going to cool off from 71 degrees. So our start was 71 degrees. And we're going to do the integral between 20 and 25. 20 and 25. And we're going to do w prime of t. I'm not going to write out all of this stuff. I'm just going to say w prime of t dt. And again, this is a calculator problem, so I can actually type this all in. There's my table. And I'm going to find the n value. So I'm going to say, I'm literally going to type all this in. 71 plus. 71 plus, and then I have to come back here and say, okay, what was w prime of t? W prime of t is 0.4. I guess I could technically type this in the normal window, 0.4, and then it's going to be times the square root of x, all of that times cosine of 0.06, 0.06x. So there's my y1 function, and then I can plug that in, 71 plus math 9, the integral of bars right, enter, take the integral of y1 with respect to, so comma, with respect to x, comma, from 20 to 25, 20, comma, 25. And I've already included the initial condition in my calculator, so when I hit enter, that is going to be my n value. I don't need to remember to add my start value. I included it. So my answer here is 73.043. 73.043. And I'll leave that calculator up so you can see the work that I did. My y1 function was entered in my y equals. Just make sure that was correct. And how to score yourself here. You get 1 point if you got the fact that you needed to use the integral between 20 and 25 of w prime of t, and 1 point if you got 73.043 plus 1. That should be technically in degrees Fahrenheit if I were to include units. But you don't need units for this one. It didn't say in here that you needed units. All right, this whole problem was out of 9 points, but you don't really need to know that. We're just showing you how to do the math. Any questions on problem 1 before we move on to problem 2? Shakes heads, shakes heads. All right, we're on to problem number 2. We're on to number A, or letter A, I should say. So for letter A, this was out of 2 points. So if you got 2 out of 2 points, you can ignore this. If everyone is ignoring this, then I'm going to go through it really, really fast. How many people got 2 out of 2? All right, so to do this one, I need to do R prime, and I think Rochelle already knows her error. Can't say that word. R prime of 45. That is going to be approximated by looking at 45. So 45 is right here. So 45 is in between 40 and 55. So I'm going to say 55 minus 40. I'm using the secant line. 55 minus 40. all of this divided by the x coordinates or the t coordinates, 50 minus 40. 50 minus 40. I don't have a calculator anymore, so I'm going to do this all by hand. 50 minus 40, 55 minus 40 is 15. 50 minus 40 is 10. This turns into the decimal 1.5. And that's going to be what are our units. So this is r prime. So r is gallons per minute. If I take the derivative, I'm adding on a minute into the denominator, and this is going to be gallons per minute or gallons per minute squared. So gallons per minute squared. All right, how to give yourself points. If you got this, all four of these numbers correct, that's 1 point. And if you got 1.5 gallons per minute squared, I'm including units as part of this, even though that's not normally how the AP graders do it. It's going to be +1. All right, from here, we move on to B. B was out of 2 points. So if you got 2 out of 2, you can ignore me. If not, you're following along with me. So we're on 2B. I'm looking for r double prime of 45. So what is r double prime of 45? So what does that mean? R prime is gallons per minute per minute. It's the change in the rate of the gallons per minute. So r double prime is going to be talking about whether or not the r prime, whether or not r prime is increasing or decreasing. So it tells us right here, the rate is increasing fastest at time equals 45. So if the rate is increasing the fastest, it's talking about rate is talking about r of t. The speed is talking about r prime of t. And if that's increasing fastest, that means we have a maximum in r prime of t at t equals 45. We have a maximum in r prime of t at t equals 45. That means if I take the second derivative, if I take the derivative of a maximum, that should be equal to a horizontal asymptote, or 0, a slope of 0. So if I'm looking at, and I kind of give you a pictorial version of what's happening here. If I'm looking at a graph, blah, 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 blah. If I'm looking at this point right here, it says, and this is going to be the graph of r prime of t, it's saying that r prime of t increases fastest right here at t equals 45. So I have a horizontal asymptote, therefore r double prime of t, r double prime of 45 in this case, has to be 0. The slope at that point has to be 0. So this is exactly equal to 0. In your rationale is because r prime of t has a max at t equals 45. That's enough rationale.
Would it be different if it said decreasing the fastest?
Yeah, if it said decreasing the fastest, it would be the same thing. It would still be 0, exactly, yeah. Because decreasing the fastest means you would have a graph that would be talking about maybe that point right there, which is also a horizontal asymptote. Yeah, awesome. And then there's 2 points here, one for the rationale and one for the fact that it's 0. Questions on B? All right, we're on to part C. Part C was out of 2 points. So we're using trapezoidal sum for this one. So again, I'm going to go ahead and write the integral between 0 and 90 of capital R of t dt is approximated by trapezoidal sum. Trapezoidal sum means I'm doing the distance between 0 and 30. The distance between 0 and 30, which is 30, that's pretty easy. And then the average value between 20 and 30. Again, the quick way of doing average is, you can kind of just see where the middle is, which is 25, or you can add them both together and divide by 2. 20 plus 30 is 50. 50 divided by 2 is 25. So I'm going to multiply these two numbers together. The distance between 0 and 30 and the average of 20 and 30. 30 times 25. So I'm going to leave that down here as 30 times 25. And I'm going to add that to the next one. So the distance between 30 and 40 is 10. So I'm going to put 10 up here. And the average between 30 and 40 is 35. I'm going to multiply 10 by 35. So plus 10 times 35. And I should be color coordinating these, but I'll start now. The average between 40 and 50, the distance between 40 and 50 is 10. And the average between 40 and 55, this is a little bit harder. I know that I go up a total of 15. So if I go up only half of that, if I only go up 7.5, because that's half of 15, I get 47.5. So I'm going to multiply, 10 by 47.5. plus 10 times 47.5. Next, I'm going to do the distance between 50 and 70, which is 20 in this case, and between...
Wait, okay, hold on. So, to get, okay, let's go from the beginning.
Yes.
So, now you do 30 times 25.
Yes.
So, you get 25 because you added 30 and 20, right?
Yes.
And then, so 55 minus 40 equals 15, right?
Yep.
You subtract it. Why not add?
I'm just doing it in a different way. I can add again. So 40 plus 55 is 95. Half of 95 is 47.5.
Oh, it is.
There's 3 different ways to do it. You can just eyeball where the middle is. You can add them together and divide by 2. Or you can look at the difference, divide that difference by 2, and then add it to the original value. Sorry, there were 3 methods there. I wasn't explicit about talking about those methods. There's many, many ways to find the average value. If you prefer me to always add and always divide by 2, I maybe should always stick with that. It's a little bit slower to do because half of 95 is a little bit hard for me to do in my head. I would have to do half of 90, which is 45, and then half of 5, which is 2.5, and add 45 and 2.5. That's how I would do it in my head. Sorry about that. All right. Are we ready for the next one? All right. Distance between 50 and 70 is 20. Then, again, I can actually add these together. So 55 plus 65 is 120. 120 divided by 2 is 60. So I'm going to multiply 20 by 60. So plus 20 times 60. And then finally, between 70 and 90, I have a distance of 20. The average of 65 and 70, and again, this is going to be, I'm going to use my shortcut method here. The total distance between them, I'm going to subtract 70 minus 65 is 5. Half of the total distance is 2.5. I'm going to add the total distance of, or add this half distance of 2.5 to the original value to get 67.5. 67.5.
I think the whole thing with this one, it'd be easier just to see which number's in the middle.
Okay, you can just see that 67.5 is in the middle.
Yeah.
Perfect, yeah, just use that then. Yeah, so 20 times 67.5 plus 20 times 67.5. Ooh, and now we need to do a lot of mental math to find this out. Do you guys want to do the mental math, or should we just get to the answer and then move on? Get to the answer, move on. I also agree. If I add all those up, I should have gotten 4,125. 4,125. We're doing integral of R of t. Was R of t a rate? R of t is a rate, so the integral of a rate is just gallons. Going backwards crosses off minutes, and I'm just left with gallons. So our units here,
Would it be gallons per minute?
it's not gallons per minute. It's just gallons. So whenever I take the integral, that's going backwards. Whenever I go backwards, I'm getting rid of the denominator. I'm multiplying by minutes. Whenever I'm going forwards, whenever I'm taking the derivative, then I add on another denominator of minutes. I'm dividing by minutes again. So in this case, I'm multiplying by minutes, so minutes and minutes cancels out, and I'm just left with gallons. And that is the final answer. Box it, move on. All right. So in terms of scoring yourself, you got 1 point for getting the answer, and you got 1 point for setting up the trapezoidal sum. All right, part D was out of 3 points. If you got 3 out of 3 on 2D, then you can ignore me. If not, you're going through this with me. So for 2D, this guy, we're going to have to find, or explain the meaning of this one. So explain the meaning of integral between 0 and b of capital R of t dt. All right, so I'm talking about R of t. R of t, again, is a rate. I can tell that because it's gallons per minute. So I'm taking the integral of a rate, and we've talked about this many times. Integral of a rate is just the total amount, the total change. So this is going to be, this means the total change, or the total amount change, so the key word here is total amount, or the total change. I'm okay with that word too if you want to use change. The total change in fuel, and if you said change, it would be change of fuel, I guess. And then what were our units? Fuel is measured, I'm pretty sure in gallons or liters, gallons in this case. Fuel in gallons, and then from the bounds from 0 to b. From 0 to b, and our units here were minutes, right? Minutes? Yes, from 0 to b, minutes. All right, so if you just said total amount or something similar to that, you got 1 point. If you got the units correct in both of the explanations, you get 1 point. And if you get the next explanation correct, you get another point. So there are a total of 3 points. So this other one, 1 of b, 1 divided by b and then multiply by the integral from 0 to b of r of t. Now it's basically the same thing. I'm taking the total amount, but now dividing it by b, which is really b minus 0. So whenever you have a fraction out front, it's usually talking about an average, and in this case, it is an average. So this thing dt means the average value. And it's the average value of whatever thing we were talking about. We're talking about r of t here, so it's the average value of capital R of t, the average value of capital R of t. And again, do your units in gallons.
Wait, average value of R of t.
Yes.
Does that mean the average rate?
Nope, it's not a rate.
So it's
Oh, it is the average rate. You're right. So R of t wasn't originally a rate. So the average rate, so you can say the average value of R of t or the average rate in gallons. You can substitute this R of t for rate if you want.
So for me, you said you put an average rate instead of average value. Is it because I didn't put R of t, so I wasn't really clear about it?
Yeah, because I didn't know if you meant R prime of t or R of t. And then from 0 to b minutes. 0 to b minutes. I don't know what I was writing there. Minutes. And again, if you said rate R of t or this whole thing, that's +1. And then if you got the units correct, so I'm talking about gallons, minutes. If you got those 4 units correct, that is another +1. So +1 for the units.
It's okay if it's just the average rate, right?
Yes. If you said average value or average rate, you get the point for this one. All right. Good questions. Keep asking them. Are there any more questions that I can answer for number 2? All right. We're moving on to number 3. So number 3. 3A is what we're on. 3A was out of 2 points. Technically, it's really out of 1 point, but I have to include the units for A and B, so I decided to put it in A. Really, A is only 1 point, and then there's 1 point in between A and B. All right, so to do A, we're talking about acceleration, and we need to estimate the acceleration. So we're estimating A of 36. So write down what you're estimating. You're estimating A of 36. Well, A of 36 is really V prime of 36. And if I'm looking for V prime, again, I'm looking for where's 36. 36 exists between 32 and 40. There's 36 right here. So I'm going to do 7 minus 4 on the top, and then 40 minus 32 on the bottom. So this is going to be equal to, well, this is going to be approximated by, so I should do my approximation now, approximated by 7 minus -4, all divided by 40 minus 32. 40 minus 32. And then when negatives kiss, they become positive. And I'm going to do 7 plus 4, which is equal to 11. 40 minus 32 is 8. You can just leave it as 11 over 8. And don't forget our units. Indicate units of measures. It says to do that right now. So if I'm taking the derivative of meters per second, again, I'm dividing by seconds again. So it's meters per second or meters per second squared. Meters per second squared. And that is our final answer. Box it. So just by getting 11 over 8, you get 1 point. The units for A and B, for part A and B, will give you 1 point. Let's talk about B and then come back and check to make sure we got the units correct. So B, we need to explain this meaning. So rewrite it. We say that this integral between 20 and 40 of V of t, dt, and a B was out of 3 points. So if you mess up on 3B, you're following along with me. So this thing means, well, we had a velocity. So if I'm going backwards from velocity, I'm talking about position. And since it's adding up all the positions, it's the total position change. So it means total position change. And then in meters. And then from where to where? From 20 to 40, and then our units per seconds, right? Seconds. So you have to say total position change, something along that line to get 1 point. All right, then we need to actually use a trapezoidal sum. So this is going to be fun. Trapezoidal takes the most work, but here we go. So we're going to approximate what thing? We're approximating the integral from 20 to 40 of Vt dt, and that's going to be approximated by, Oh boy. And it's only 20 to 40, so we're not doing the whole thing. We're only doing this part right here. We're not doing 0 and 8. So first, I find the distance between 20 and 25. That's going to be 5. And I'm going to find the average of negative 10 and 8. I just see that negative 9 is the in-between number. So I'm going to multiply 5 by negative 9. So 5 times negative 9. I'm going to add this to the distance between 25 and 32. Well, the distance there is 7. And the average of negative 8 and negative 4 is negative 6. So I'm going to multiply 7 by negative 6 plus 7 times negative 6. All right, now I'm going to add it to the distance between 32 and 40, which is 8. Okay, this one is going to be a little bit trickier. I'm going to add these and divide by 2. Negative 4 plus 7 is 3. 3 divided by 2 is 1.5. 1.5 times 8 is what I'm looking for, so 8 times 1.5. And I need to do this all by hand. If I do that all by hand, I should get negative 75. And don't forget our units, which are going to be meters. All right, how to score this one? You get 1 point for total position change. You get 1 point for setting up the trapezoidal sum, 1 point for getting 75. And if you got the units correct, meters per second squared and meters in this one. So I'm going to do an arrow, meters per second squared. Those both are +1 for the units. And I put that in the A category. That one was out of 2. All right, we're on to part C. So 3C, if you got 2 out of 2, you don't need to follow along. And I mean, you can if you want, you can still learn. So this one, I'm talking about the entire interval. Where must the particle change direction? Okay, well, normally we don't need to say velocity equals 0. We don't need to use MVT, but generally speaking, we're just looking for when you start changing direction. So we notice that we're increasing, and all of a sudden, right here between 8 and 20, we have changed position. We are increasing, now decreasing. Okay, from negative 10 to negative 8. Oh, now we're increasing again. Between 20 and 25, we started increasing. We were decreasing. Wait, am I thinking about this right? Oh no, we're just looking for v sign change. I was thinking about position for some reason. This is velocity. So where do you have a v sign change? It was positive here, it's negative here. Negative, 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 good. Oh, now we have another v sign change. It went from a negative to a positive. And you think about this as if I were walking around. So I am walking as a positive rate. Now all of a sudden my velocity is 0 and I am going backwards. Now my velocity has become negative. I went from a positive to a negative, therefore I have switched directions. So whenever I have a v sign change, I have switched directions. That's all we're looking for, v sign change. And there are 2 of them. One of them was between 8 and 20, the other one was between 32 and 40. And then we'll write that down. Change direction. You don't need to write this for the AP graders, but it is helpful for our notes. Change direction is the same thing as a v sign change. All right, so where does that happen? That happens on the interval between 20 and 30, or sorry, 8 and 20, 8 and 20, and 32 and 40. So we're going to say for those intervals, direction changes on these intervals and why? Because v or velocity sign change. Sign cannot spell sing. Sign change. I changed my singing. I'm much better now. I am really good at singing Disney songs. I've been singing them every day. Riley enjoys them. All right, so you get 1 point if you got both of these intervals. If you put the interval between 8 and 20 and 32 and 40, give yourself a point. If you said something like v sign change as your reason, give yourself a point. That was the 2 points. And we're almost done with the free response. We're on 3D. This one is technically out of 0 points, but I want everyone to pay attention.
Yeah, I got this one.
I want everyone to pay attention. Yep. This one was hard. So we're supposing that the acceleration of the particle is positive. So we have information that we didn't have before between 0 and 8, right? So we're just talking right now about this interval on 0, 8. We know that between 0 and 8 we have a positive acceleration. If we have a positive acceleration, that means what about v prime? If a of t is greater than 0, then v prime of t must be greater than 0. Okay, so let's go ahead and just calculate the, I guess we don't really have the best way of doing this, but let's assume that we just have a flat bar at 3. So if I'm looking at the graph, the bar is going to look like this. So I'm at position 3. That was my starting value. Or sorry, at position 0. What am I saying here? At the t value of 0, I have a height here of 3. Let's assume the worst case scenario, that it was basically a flat line. It was basically a flat line until you get time equals 5, or until you get time equals 8. And then it jumps up here to 5. Let's assume the worst case scenario here. The worst case scenario is I've only traveled like this. The way that I set this up is I'm basically doing a start plus change equals end. So for my time, start plus change equals end. So at time equals 8, my starting value was 7. It tells us that up here. My starting value is 7. So my start is 7, and I'm going to add the worst case scenario here, 0 to 31 of dt. What am I saying? Vt dt. The worst case scenario for this thing, we can say that this integral between 0 and 8, why did I say 0 and 31? Sorry about that, 0 and 8. The worst case scenario for 0 and 8 of Vt dt, this thing has to be bigger than that worst case scenario. The worst case scenario was, this was 3 times 8, which is 24. The worst case scenario was this integral, this area of this block was 24. That means that this integral has to be at least bigger than 8 times 3. It has to be at least bigger, which is equal to 24. This integral has to be bigger than 24. Can we all agree that it has to be bigger than 24? Because we know that the velocity should be increasing since the acceleration is bigger than 0. The worst case scenario is that it's 24. So that means if I actually added this all up, let's change this integral out for 24. 7 plus 24, what is that? That's 31. We know that it has to be bigger than 31 since v prime is bigger than 0. We know that it has to be bigger than 31, so it definitely has to be bigger than 30. How do we say that? We'll just say that 31 is definitely bigger than 30. And since we've already included the fact that this is the worst case scenario, we basically have our explanation. I know that I explained it in words, but if you have this work on your paper, you should get the points. All right, so if you said something along the point of a of t and a of t is the same thing as v prime of t, you actually get a point. This is actually in the solution guide for the AP graders. If you said a of t and v prime of t are the same thing, you got a point just for saying that. And then, of course, the hardest part is doing all the explanation, using the fact that it's the worst case scenario was 24, adding that to start plus change equals n to get 31, and 31 bigger than 30. All of this explanation gives you +1. And that's one of the general ways of doing a proof. Assume the worst case scenario, that way you have to be bigger than that. Or assume like the biggest possible thing, so you have to be smaller than that. If you're trying to get something bigger, if you need to be bigger than 30, assume the smallest possible case, that way you know you're always bigger than that. If you're trying to get under something, assume the greatest possible thing, that way you're always going to be under it. All right, so let's do the multiple choice. We're going to have to do these really, really quick. I think everyone got number 7 correct, or what am I saying? Number 4 correct. So I can do this pretty fast, but this is just the rules as I go to infinity. Horizontal asymptote is when I go to the infinity, so it is 7. It has to go to infinity, so it's either, what am I doing? I want to do blue. So it has to be B or D, and it doesn't make sense to be -7, so the correct answer was indeed E. Any questions on number 4? All right, number 5. This one we messed up a little bit. This is quotient rule. Whenever you see something on the bottom that you can't bring to the top, you need to use quotient rule. What's quotient rule? Shout it out.
Low D high times high D low.
Low D high minus
High low.
high D low
Oh, high D low.
all over
Low low.
low low. Yep, there it is. So if I do that, I get low is x squared plus 1. Derivative of the top is just 1. So it's just this times 1. That's going to be subtracting high, which is x plus 3, all that times the derivative of low, which is 2x. Yep. All that over low low, which is x squared plus 1 squared. And then plug in -2 immediately. When I plug in -2 squared is
4.
plus 1.
5.
So this whole thing is now 5. If I plug in -2 plus 3 is 1.
4.
-2 times 2 is
-4.
-4. So this is a minus 4, so it's going to be 5 plus 4. I now have 5 plus 4 on the top. And then on the bottom, when I plug in -2 squared again is 4. 4 plus 1 is 5. 5 squared is 25. That is 9 over 25. Correct answer is E. Number 6. All right, so this one I think everyone got as well. This is just definition. If I go backwards, if I take the antiderivative of lowercase f, you get capital F. That's what this thing right here is trying to say. So that means I'm going to get capital F of x evaluation bar between a and b, and you plug in b and then a, so it's going to be b minus a. Where is it? It's D. No questions on 6? All right, number 7. A few people got this one wrong. So this is the graph of f prime. So if I'm looking, I need the definition of max. What is max? F max. What's the definition? Shout it out. F prime
Is greater than 0.
is greater than 0. No, that's increasing. Say, yeah, so it's f prime sign change. F prime sign change is relative extrema, so that's relative extrema. So f prime positive to negative is a max. What about a min? F prime goes from negative to positive. Perfect. Negative to positive. And since this is f prime, we're just looking at the heights. Where does the height go from a positive to a negative for the max? Where does the height go from a negative to a positive? I went from a negative to a positive right here, so that's a min. I went from a positive to a negative right here, so that's a max. I went from a negative to a positive right here, so that's a min. So there are 2 mins, 1 max. Where is that? 1 max, 2 mins. There it is, A. Questions? And then our last question, number 8, we need to find the total distance. Okay, there's 2 different things. There's total distance and there's total displacement. Total distance means absolute value. Everything is positive. If you have displacement, then you'll have negatives. Negatives are allowed. Negatives are allowed. Since it's distance, everything is positive. You break this up. This is going to be 2 times 3, 6, divided by 2 because it's a triangle, that's 3. This triangle, or this trapezoid here is 2 by 3, 6. This triangle is the same thing, 3. This down here is going to be 2 by -1, which is -2, times, or divide by 2, it's -1. But that -1 is now a positive 1. This thing is positive because we're talking about distance. If I went all the way to the wall and back, and I asked what was the distance that I traveled, I count all of that, even though I had negative value. Displacement, I'm still here. So the correct answer is 3 plus 6, 9, plus 3 is 12, plus 1, 13. Correct answer is B. Any questions? All right. Fix up is due tomorrow. Yeah, tomorrow. Test is on Friday. It's not the best case scenario, but test is going to be on Friday. It's going to be tomorrow. Study tonight. Do the pretest again. It's online. You can print it out right now if you want to take it again. If you take the pretest again and you still want to study more, do the self-checks.